Hello, everyone. My name is John Rodriguez. I work at Square doing Android things, and today I'm going to be talking about the Android Gradle plugin. I gave a pilot of this talk a few weeks ago in DroidCon London, so if you saw that talk already, don't worry. There's a lot more content here, new content. So I am renaming this talk to a deeper dive into the Android Gradle plugin. Cool. So let's start off with how many people are using Gradle in their day-to-day Android development? Cool. How many people feel like they still don't know a lot about Gradle? Cool. So hopefully today you'll pick up some tips that I work on the Cash app at Square, and my day-to-day isn't build engineering, but a lot of times Gradle forces you to kind of get into the weeds, and there's not much documentation, or if there is documentation, sometimes it's out of date. And so this is more like a lessons learned type of thing. Also, unless you work on Android at Google, chances are you're using the Android Gradle plugin. And so if you don't have a build system or a team to help you out, your side projects or your open source repos will still likely use the Android Gradle plugin. So you're likely to encounter it whether you maybe care to or not. There's not a lot of documentation, so let's dive right in. When I gave this talk a couple of weeks ago, I posted on Twitter what they wanted to hear, the community, on the Android Gradle plugin, and the common resounding theme was, Android Gradle plugin, just help me Gradle. And so we're going to spend a little bit of time just going over like fundamental Gradle stuff. Obviously, it's about the Android Gradle plugin, but I think that if we highlight some basics, it'll set the stage for the rest of the talk. So to start, every Gradle build consists of 3 build phases. We have the initialization phase. That's when the Gradle is going to execute your settings file, parse all the projects that it sees in the settings file. Each one of those include statements is going to result in a project instance. That's the model that Gradle speaks. So if you have 140 modules in your code base, each one of those modules is considered, from Gradle's perspective, a project. And that's important to know. You know that it's a project because it has a build.gradle in its folder. There is probably a root build.gradle, and therefore it's the root project. And while you can do nested projects, most of the time after the root project, you're flat from there on. Initialization is pretty straightforward. The tougher part is configuration. That's where a lot of people tend to trip up. During this phase, all the project objects are configured. Every build script of every project is executed, regardless if the project may be the one that you're trying to build. That is by default, because Gradle wants to know, it's basically very open-ended, and by default, the configuration of any project has to happen before any task is executed. So, from a single task, from a single project request, all projects are configured, and that's to maintain that flexibility. There's this concept called configuration on demand that attempts to only configure projects that are relevant for your requested tasks. It would only execute the build.gradle file of projects that are participating in the build. And this way, the configuration time of a really large build can be reduced. It does so by following a few heuristics. It obviously always has to configure the root project. It looks at things like what are your project dependencies. So if you have compiled project A, then obviously it needs to pull that build.gradle in and execute it. If you have anything like task A depends on task B, then it has to infer, okay, I got to read that script as well. Chances are, unless you're using a plugin that's gone awry or you're writing tasks in a suboptimal way, the amount of time that you're saving by using configuration on demand versus configuration is usually in the order of like a few seconds, whereas your full build is probably taking minutes. And so there's probably a ticking time bomb somewhere else. That being said, some third-party plugins also don't necessarily Gradle well. Let's see. Did I skip a slide? No. Cool. One of the things that you're going to run in the configuration is the build script dependencies. And so that block, build script, is only logic and only the plugins related to the build scripts. None of these things will actually wind up in your artifact. It has its own class path to do so. One thing you should know is that even if you're running Gradle help, you're going to download all the build script dependencies first. So it may not make sense to download the Android Gradle plugin for the first time, or SQLite, or your Verges plugin, but Gradle doesn't know that. It doesn't know until it configures everything how to actually execute the command. And so that might seem a little odd the first time. In previous versions of the Android Gradle plugin, it would also download all the dependencies that you had referenced in your project. That has since been deferred to the execution phase. We'll talk about that more a little later. Aside from the runtime dependency resolution, nothing else will happen unless you have custom tasks or you apply a plugin. Plugins are extensions of your build script. It will then add tasks to your project and link them to other tasks using something like a task dependency. This could be useful for things like CodeGen, and Kotlin multi-platform is a really popular example lately. Sample plugin, a Hello World plugin, just to kind of get everyone familiar. This is what writing a plugin would look like. It has an apply method. It passes in an instance of the project. You can, the thing is everything's centered around the project. So every project has a build.gradle. A project has many tasks. A project has many extensions. Everything is rooted on the project. And so here, we are registering a task on this project. And so if you're running the help command, you're technically registering the help command on every one of your projects and then calling it on the root project. It may seem a little non-intuitive, but we'll see how this becomes a little helpful with some logging. So once you actually declare the plugin, you have to apply it. You usually don't see this notation because the project scope is implied, but it's helpful to know that when you're applying the plugin on an instance of the project, and you're creating one instance of the plugin. So if you apply a plugin to one project and you apply the plugin to another project, you created two instances of those plugins for the scopes to the individual project. Most plugins need some configuration from the build script. One method for doing this is using an extension object. Just think of it as a POJO. You then, after defining that extension object, register it to a namespace. That looks something like this. So now we can read customized input from the extension. Again, as Android developers, you're used to that Android block, your default config, all that. These are the Android Gradle plugin will provide extensions, and you configure the DSL, and then that information is pulled into the plugin to configure itself. Yep, so then you could pull the information from the extension. That namespace that you registered is what the name of the closure will be in your configuration file. So since I called it greeting here, that's why the closure block has greeting before it. It's very useful if you look at the Gradle source. Each project has an associated extension container. This contains all the settings, and that's how you can see that a project has many plugins and a project has many extensions. And you may not have noticed it before, but the Android Gradle plugin has better documentation over the last year, and it's kept up to date with every release. So if you go to the DSL, you'll see that, for example, in version 3.2 of the Android Gradle plugin, they've added some new attributes. So I'd keep that handy. I'll be posting my slides as well after the talk, so all the links and code snippets will be shared. And so things like when you apply library settings or app settings, they have their own extension types. Moving forward, you may create your own tasks in your build script. Usually you'll embed them inside the Groovy files because that's just what you copied off of Stack Overflow. That's great in getting you up and running, but it's really easy to actually set some bad patterns unknowingly. For example, one of the most common ones is you put code that you want to execute in the execution phase, but you put in an area that winds up having it run during all the tasks being configured. And so what does that even mean? So eventually, after all these tasks are wired together, you have this huge graph. And this huge graph is like the super graph. And then whatever you typed on the command line is going to then walk that graph and only execute a small part of it. And that makes sense because you only want to, if you're running test, you don't want to run the assemble command. Or if you're running help, you don't want to run the test command. But if you put logic in the configuration part of your task, you're going to run that no matter what command you run because of what I mentioned earlier. You have to run all the configuration for all tasks before you do any command. And putting your custom task code in a build.gradle in like a Groovy snippet just makes that more error prone. And so A nice to have is move those tasks out of your build scripts and move it into your build source directory or into a separate plugin project. And in doing so, you have a more expressive declaration, you have appropriate inputs with the annotations, marking them, and then also you can write tests against them, something that you can't really do when they're embedded in your Groovy scripts. Quick look at the SQLite plugin. We're not going to go too deep into it, but it's just nice to see a working example and not just a hello world example. If you're not familiar with SQLite, it's a plugin that we use at Square to generate from SQL files, Java or Kotlin models that we can then work with. And so instead of having an ORM model, we just have type safety to database tables. And so this plugin, like all the other plugins that you use on Gradle, will have this apply method, pass in the project, create an extension, and then we'll talk about the after evaluate block. So after you finish configuring all your tasks, there's almost like a second pass at configuring your tasks. And why does that even happen? Why do you have two phases of configuration? Well, Gradle doesn't know the order in which your projects are gonna apply the plugins. And so some things, some code, some configuration needs to be executed after all the plugins have been applied and everything has been evaluated. And so, for example, in Android, the concept of a variant, which we'll talk about more, will only exist after you've done your initial configuration sweep. And so a lot of times you'll see, I'll show you an example later, the task that has debug or release or whatever segment in the task name, that task has to be created in the after evaluate block because it has to get the layout of the world first. In this case, in the after evaluate block, we look at and see, SQLite looks at and sees, okay, is this an application or is this a library module? If so, get the appropriate variant type. You're an application variant or a library variant, and then configure Android accordingly. This is a big block of code. All the points that I want to mention is that your plugins can add more dependencies than you explicitly listed in your build.gradle file. So that's something to know. And if those plugins do it in in the Android or the AGP 2.3 way, that could slow down your build too. So that's why it's worth knowing and looking at your plugin source to see if it's up to date. Not only can it update dependencies, but as I mentioned before, it can register tasks. Another thing that's important to know is if you're in Android, your task names should probably have the variant name embedded in it. Otherwise, you'll have bugs where if you want to create a custom task and you run assemble instead of like assemble debug and assemble release, what happens is when you run assemble, it's going to run all the variants. And so it will try to configure, task foo for assemble debug, and then try to configure foo again for assemble release. And then I'll say, wait, I have two tasks with the same name, and it'll error out. And so on Android, if you're creating a custom task, you should probably just embed the variant name as you see there with the it name capitalized. And you realize that most of the Android Gradle plugins do similar. Okay, so that was a lot. Configuration is the most complicated part of Gradle, which is why I went into it in a bit of detail. So just to recap, it evaluates your build scripts, it applies plugins, it runs the after evaluate blocks, it'll connect tasks to your project, and on Android, many tasks with the variant awareness will happen in those after evaluate blocks. Execution's easy. Once you have the graph interconnected, you look at what was typed on the command line, and then you can walk the graph backwards. Basically, in order to do assemble debug, I have to do this, and in order to do that, I have to do this. And then you go all the way to the very start of the graph and walk it, satisfying it, executing whatever you need to do. So that's great on a high level. If I didn't lose you yet and you wanted to go home and like play around with your Gradle scripts, one thing that I like to point out is the notification callbacks on Gradle are very helpful. Just register listeners and log everything. And it turns out you can learn a lot of how Gradle's lifecycle works just with this. A good example is if you just create an all projects block and you register for whenever a task is added and add this after evaluate snippet, what I mentioned earlier about how Android tasks work, you'll notice that before the ellipses, there were tasks that were added while configuring the Android library project, and then you'll see a printout saying just evaluated, and then you'll see more tasks. And at first that didn't make sense to me. I said, I thought a project evaluation would happen after all the tasks. Well, that just means that everything below the ellipses was in a after evaluate block. And so anything that wasn't inside the block was added to the task graph, and then all the other tasks, which had to be variant aware, were in after evaluate blocks, which is why you'll see them, half of them are above, half of them are below. So again, just trying to understand like the ecosystem is useful to then debug larger problems. Quick recap of variants. Kind of went through that. No. Cool. Build types allows you to build your app in different modes. You know this, you get it for free with Android. So debug builds, you can do cool things like have a debug drawer, have a debug signing key, and then when you go to push to the Play Store, you sign it with your actual signing key, and maybe you want a ProGuard for release, but not for debug because that's slow, or what have you. So you're familiar with this already. You may also use product flavors. The canonical example on the Android documentation is you have a free version of your app and a paid version of your app. At Square, we have like internal, which we ship to like internal alphas, where we can do things like a 2-finger file that will automatically submit a JIRA to the team from our PMs or anyone in the company. And then our production version, which is what we obviously push to the Play Store. And so you have the build type dimension and then the product flavor dimension, and then they form this two-dimensional matrix of build types and product flavors, the combination of which is a variant. And so if you didn't know what I was saying when I was saying variant, it's this. If you don't have product flavors, that's fine. It's just empty string. Then your variant is the same as your build type. But if you do introduce this new dimension of product flavors, then it's the cross-section. So as a result, this gives us 4 variants. Let's talk about how we can debug some builds now. Let's go a little deeper. So we all know how to run a task in Gradle. But if you want to debug Gradle or any plugin like actual software, did you know that you can add this option? And now Gradle daemon will stop. There's a couple of other things. You should also disable the daemon. And depending on what you're trying to debug, you should also disable the build cache and disable up-to-date checks. Because if you run something and realize something looked a little odd, but then your attempt to debug it, you actually won't rerun the task that you set the breakpoint in. You're probably going to be confused for a little while. So make everything a clean build, essentially, by passing these arguments. And now the Gradle process will wait for you to hook up a debugger using remote attach. And so you'll see it hang. You go to your IDE, create a run configuration, and then voila, now you can hook into the Gradle process. The Android, one of the things about Gradle at the moment is that the build script dependencies do not download sources. And so retrofit on Maven Central, you add it to your dependencies block, you'll get the sources if the author published the sources to Maven Central or JSON or what have you. But build script dependencies don't do that. So, but for free, you don't get the Android Gradle plugin sources, but with this hack, you can. Instead of adding the Android Gradle plugin to your, well, in addition to adding it to your build script dependencies, also add it to your regular dependencies as a compile-only dependency, and now you'll pull down the sources. And with the sources, now you can start debugging like actual software, which is really helpful. A couple of other tips before we move on. I keep on mentioning there's a task graph, and that's great, but it's always, visualization is always helpful. So there are 2 little tricks that we could do. If you're familiar with graph viz, as long as your graph isn't too dense, and so real production projects quickly overload this, but if it's small enough and you can contain your example, you can visualize it by iterating over your task graph, looking for every task's task dependencies. So basically, for every task, what task does it depend on, and print it out, which I'll have some snippet to share after the talk, and print it out. You can get something as simple as this for, say, a simple Java module. And so now we can reason about this. We can say, okay, well, it makes sense that the first steps in building a jar would be compiling some Java, maybe some resources, putting those classes together, calling a jar command which zips everything up, and that's what assembly is. And so if you're familiar with Maven or you've written plugins before, you may realize that there's something called anchor tasks, which are really dummy tasks to allow other plugins to hook into them. And so really it turns out that the Java plugin provides these 2 anchor tasks, and then the reason for that is because, if you ever did J2E programming, besides a jar, you can have a war, you can have an ear file, you can do some custom stuff, and so every Java plugin has to have some concept of classes and assembly, but how that output artifact is going to look will depend. When you run the jar command, it will obviously be a jar, but it could be something else. Now let's take this to a big concept. This is a simple Android application module, doesn't even have an activity, and it has a dependency on one Android library module, which also doesn't really have much in it. This is the task graph. One thing to note is, well, obviously you can't read it, I don't expect anyone to, but running the build command, if you run assemble, it's gonna do both variants, which is why it's so large. It's better to run assemble variants instead. However, this is nice to see. If you zoomed in, you'd see that like basically the debug tasks are at the top and the release tasks are on the bottom, and they're pretty much duplicate. We'll come back to this in a second. Now that we have some idea of visualizing the graph, can we do more? Well, when you see assemble debug or process resources, it's not really clear what task that actually maps to. So if we update our script and not only show the start commands that we pass on the command line, but also print out the task name and the class of the task, now we can get really helpful output that looks like this. And now I know that now that I have the sources for the Android Gradle plugin and I can hook a debugger to it, now I can just command O and IntelliJ and open the class of the actual task. So now that I know if I like process resources is causing me problems, I just open the process resources task. Now you might be like, did you really need to print that out? There seems to be a pattern, but not all the tasks are just like the lowercase or the uppercase version of the class name. So don't rely on that, just a pro tip. But it usually correlates. Another thing to notice is that, again, the variant-aware tasks stand out here. Another thing to point out is default tasks. Default tasks are the anchor tasks. And so if we take this knowledge, one thing before I go forward, we may also want to know the inputs and outputs of our task. And so we may be tempted to then add a similar code like this, and you'd be surprised when it blows up. And then you'd have to step back and say, wait, why did this blow up? Everything was working so well. Well, the problem is that when you refer to the input file collections in this part of the code, the task graph, when ready, is just at the final part of the configuration phase. So you were trying to resolve a dependency while you're still in the configuration phase, which is a no-no now on Android as of AGP 3.0. And so that's one of the things that the tools team at Google has been working very hard on, is that build speeds were poor because everything was aggressively resolving dependencies even when it didn't need it. They're trying to be smarter about it. They deferred it to lazy resolution, but now you can't do things like this because you will be going back to that eager behavior. So how do you do it? Instead of trying to print the inputs and outputs of the task when it was just added to the graph, get the inputs and outputs when the task is executing, which makes sense because by then it will have resolved those dependencies. So it just means the output is going to be a little later in your console, but that's okay because you're just debugging anyway. Here's an example. Who knows what this task is? It doesn't really matter, but it's nice to know what the input files are and the output files. I find the output files or directories more important because now I can, ls into it, cat the output, try to reason about it. What is this? And I think that just the more tools you have to debug, the better. Another thing that can confuse Android developers, I've mentioned this thing called a configuration. I think, think of a configuration as just a container of dependencies. It could be local dependencies or remote dependencies. And the most common ones that we encounter on Android is the idea of API and implementation. There are others, but let's forget about those. For example, if you have test implementation, you can reason, all right, well, that's like implementation, but for tests. Capped, if you're using annotation processing on Kotlin, you're familiar with, but let's just stick with API and implementation. So if there was a blog a year and a half ago, I think, that came out that explained this really well, so I just borrowed the visualization. But the concept of knowing the difference between API and implementation is knowing what an ABI is, and that's an application binary interface. It's like the contract of a module to another module. It's no different than having an open source library, but it's sometimes hard when it's within your app to treat parts of your apps as like APIs to each other. If you do this right, though, it can have some marvelous benefits. So let's first define ABI. ABI is pretty much anything that's public, not just the method signatures, not just the fields, not just the annotations, but also the supertypes. And this is what trips up a lot of people, is that if, for example, you're exposing an observable type, then you need to leak your RxJava dependency through from one module to another. And that would be like, why do we need to do that? Well, it's because how else will I be able to get the observable type on my class path? Well, you might answer, actually, I'll get to that in a second. But basically, if you do this right, then when you make a change in that leaf node at the very bottom, the build update, the incremental build should be localized just to that node. It shouldn't have to build the whole thing. That's not the way it used to be before AGP 3.0, and that was one of the problems they also try to solve. I think it's compilation avoidance, and so the problem is that the compiled configuration is equivalent to what API is today, and what they've introduced is that concept of implementation. And so if you have an implementation dependency, that means, as it implies, the dependency is only for my internal implementation. The outside caller does not care about it. And so therefore, that dependency does not leak onto the compile class path of that consumer anymore. So you will never accidentally depend on that dependency. Also, because you have a reduced class path size, which can get really big in a large project, you have faster compilation. And also, you have less recompiles because it can be smart about what part of the graph it needs to traverse. So let's look at an example. We have a very simple app module that has a dependency on some API module. The API module just pulls in retrofit and RxJava, and then to the right of each of those modules is a very trivialized example of I have a retrofit service, and then somewhere else I consume that service. Okay, turns out this will fail. Why is that? For the same reason I just went over. Because the API module is not using retrofit call, it's using the RxJava adapter and therefore exposes observable. And so to expose observable to the app module, where you see then it calls app service.register SMS, then it probably will call subscribe at some point. It doesn't know about the observable type as is. So how do we fix that? Well, we change that implementation dependency to become an API dependency. Some people might say, well, why do that? Why not just add Rx to the app module? Wouldn't that be the same thing? Depends on what you're trying to solve. If you're just trying to get it to build, sure, but that's not the right way to do it. Why should the app module know about, it may know about Rx for other reasons, but for this example, the only reason it would ever know about Rx is because the API module is informing it of Rx. And so having the app module have to explicitly declare Rx is a smell. You should keep this like an API. If it's using the API module, it's going to know about retrofit, then it's okay to know about observable from that module only. It doesn't mean you're going to have API dependencies everywhere. You're still going to have them only in a few places, but it's good to be aware of that. Also, retrofit exposes HTTP objects like HTTP exception and call factory, so we probably want to update to be API as well. It makes sense that the API module would expose its dependencies as API, right? But don't do this everywhere, otherwise you fall back to the AGP 2.3 behavior. Okay, so let's go back to this graph and start digging even deeper. I'm running slow on time. So let's try reducing this. Let's only focus on the debug build type, and also instead of looking at an application build, let's look at a AAR build because you can reduce a few things. We'll mention some of the APK tasks. We get a graph like this, and if again we focus on those anchor tasks, we see that it looks like something like this. So okay, it makes sense. The core of building an AAR, you need some resources, you need some sources, and probably some assets, and then it gets packaged. Very generically, that's the base of what's building an AAR. But then you'll see that this graph is still rather large. I'm not going to go over every single node. Let's just go over a few. Check debug class path. It's not the most interesting task, but I bring it up because it's small enough to start talking about the Android Gradle plugin's infrastructure a bit. So if you open up that task, you'll see there's a task action that's a one-liner, compare class paths. And so what does it do? It calls this method compare class path and looks at the runtime and compile class path. Okay, what's the difference there? Before I answer that, I want to point out a couple of other things. So the configuration phase of Gradle still applies here. The way that the Android Gradle plugin does it is it encapsulates it inside a task config action, which you see up there. And so that execute block is not the execution phase. That's not what the task is executing. It's executing the configuration. So we're still right now only looking at the configuration of this task. And so what you could see is like the prefix and suffix. Now you can see why I would say check debug class path or check release class path, because one of the things that every Android Gradle plugin task does is it has an idea of the variant. The variant scope, you get the class name with a prefix and a suffix, and it just concatenates it. So that maybe makes a little more sense why you sort of debug and release always in the middle of those task names. In the bottom, you configure the task by giving it awareness of the variant so that it can do the same thing. But also to configure a task that checks class paths, you need to give it the class paths, the runtime and the compile one in this case. So there was an issue that was filed, and there was a warning introduced into the Android Gradle plugin 3.2, and it's soon going to be an error. And that prompted the creation of this task. So what is this task? It turns out if you have different versions of a dependency in different modules, or if you had the module or the dependency listed as an API somewhere and an implementation somewhere else, you could get this weird problem. To illustrate this concretely, let's say we have something like this. Module A retrofits an API dependency, OKHTTP implementation, and then B has an implementation on retrofit, same version, but then we have this dependencies closure in the app module that depends on A and B. So there's a command called dependencies. If you haven't run it, it's also very interesting for debugging purposes. If you run this and then you look at this is gonna spit out a lot of content. I've reduced it to illustrate my point. You'll notice that if you're on the compile class path, because it explicitly mentioned OKHTTP, I'm sorry, the other way around. The runtime class path, because it explicitly mentioned OKHTTP, will have a later version. And so there were times where you wouldn't catch bugs at compile time, but when your app ran, then it crashed. And that's never a good thing. It came up a lot, especially with ProGuard and R8, because it does a lot of inferences based on the bytecode. And so there's a risk of runtime bugs. And so now the AGP is gonna, if you haven't updated to 3.3 yet or Canary, when you do, you will probably be annoyed by the fact that this will start failing your builds more prematurely, because it'll notice a discrepancy between your compile and your runtime class paths. There are ways to fix that. Either include that dependency as a first class dependency in your script, look at the dependencies output and see what you can configure differently. The issue that I linked there and that I'll be sharing on the slides later you can follow that issue on the Google issue tracker. It's also helpful to know how these configurations are interrelated. So the green is what you actually put in your config script. The pink is actually what Gradle does at runtime. So the way that Gradle configures internal class paths differently. Once you set up your build scripts, the consuming module is actually going to have a different class path than yours, because, for example, like the Android SDK doesn't have to be bundled in your module, but it knows at runtime it has to run it. So they should almost be 100% similar, but at times they can be different, and you should know that. I just like to refer to this graph whenever something confuses me, and then I just kind of reason about it that way. All right, let's move forward to more AGP tasks. So the res values task. It's an anchor task, or rather there's a debug resources anchor task that res value depends on. What is res values? So one little known feature of the Android Gradle plugin is that you can generate dynamic resource values at build time to consume at runtime by setting a property like this. Note you should exercise caution if you're going to use this in prod builds, because if you don't use static values, this could force Gradle, or rather, this could prevent Gradle from being able to determine that something's up to date, and so you're going to force a clean build when you shouldn't need to. Like, for example, if you're doing timestamp checks or git SHA checks here so that you can show something in a debug drawer. So there are workarounds for that, but it's useful for other things. So if you include that, there's a task for this. It's called generate res values. And so we know about the task config action already. We mentioned the variant. No, now there's this concept of variant data. So like what you put in your debug block and your release block, all that gets bundled together in this thing called variant data and provided to the task. And so it's looking for the configuration. The Android builder is this like externalized part of the Android Gradle plugin. It does all the building. It does the dexing, it does the resource merging, and so it's configuring that. One thing you notice if you break points here is that you will hit that breakpoint for every single variant because again, it's configuration. So you'll hit debug, you'll hit release, you hit unit test, you hit Android test, and you'll be like, why am I executing this 4 times? This is why in Android Gradle plugin 3.3, they're moving from task to task provider so that they can defer even the configuration of a task. And so that can result in even bigger gains on the plugin setup. But I just wanted to point that out, that if you do debug this, you will hit it 4 times and it may not be apparent why. If we dig in deeper, we'll see that that res value that we provided in the script maps exactly to the type name value that this task is adding to a list. And then it just dumps it to an XML file that's named generated XML resources, resulting in something that looks like this. If we cat it, and since we had the inputs and outputs of the task, we can find that directory fairly easy and then just look at it on the command line. Again, trivial example, but it's interesting to see how your build scripts then actually result in these generated XMLs. Moving on, something a lot more complicated, package resources. If we go to package resources, we'll see, again, that's why you can't depend on the pattern. It actually points to a task called mergeResources. And so if you go to mergeResources, one thing that's really interesting is it's an incremental task, but we won't go into that because that involves a lot more like insight into the plugin. Let's just look at what it does on a full task action. Well, so there's a resource preprocessor that's useful for, say, if you're a min SDK lower than 21, you need to rasterize vector drawables to pings. That's what the resource preprocessor does. It does all the things for like lower SDK versions. And then it has this class called a resource compilation service, which is very intriguing. Aside from that, it does what you would think mergeResources does. It reads your resources from disk. It adds it to a data set to this thing called a merger. Whoa, what does that do? It probably merges. And then writes it to a writer, which is probably going to write it back out to disk. So it takes files in and merges it and writes it out. But again, I want to really dig into what is this resource compilation service? That's the most interesting part. So we look at this, it's an interface, and we see that it has 2 methods. It has a submit compile and a compile output for it. What is that? Well, it's an interface, so we can look at all its subclasses, and we'll see right away that 2 subclasses that jump out are a resource compilation service that just copies files around, and another one that works with the AAPT2 daemon and Gradle worker. So that seems a lot more interesting. Let's dig into that. One thing to note is what I then did from here is go to every implementation of that interface and set breakpoints in those 2 methods, because I don't know how it's going to work and how it's going to hit. That's how we just debug and troubleshoot. In doing so, I also realized in that java.comment, comment, you may have missed it, the last green comment, it mentions AAPT do daemon. So let's command O that, and we'll see that it delegates most of its functionality to these 3 methods. And so now this is looking like shell commands, and then this is kind of intriguing. So that means that the Android Gradle plugin actually shells out to something on the file system, probably provided by the build tools of the Android SDK. And so AAPT2 is actually now an independently managed Maven artifact. You can prove that to yourself by looking at the inputs to that task. And you'll see that the very first thing is a versioned AAPT2. So now you know, okay, I depend on AAPT2, which I haven't yet covered what that is, but the TLDR is it's the thing that does the resource crunching, and some directories, and it's going to spit them out to some other directories. So how do we make sense of this? Well, basically, I LS'd and catted each of the directories until something like stuck. And this is what you see. You see, if you add, in my trivial example, I added a linear layout and I added some strings. And remember, I also had that res value in my build config. And so you'll see that 2 of the strings in my strings.xml plus 1 of the res value resulted in 3. Oh, one thing I didn't do is I show you the input. Sorry, slides jumped ahead. Jumped ahead again. Cool, there we go. I had 2 separate strings files and a separate layout, and I had the res value, and the whole point is it's merging, so this is the input, and that's the output. I don't know why my slides keep on jumping on this thing, but all right, well, that's not important. This task actually runs a second time. To back up, when I set those breakpoints, I noticed that it was getting hit 3 times during the entire build. And that was also confusing to me. So the first time it was copying and merging locally the Android library modules resources and just copying it like 2 things, putting it together, keeping it inside the module, great. Then it hit the second time, but this time it's running a task on the app module. And so I noticed that one of its inputs consumes the output of the previous run of the task. So it makes sense. The library produced a merge resource, and now the app is consuming that merged resource, and it's going to output it somewhere else. So if I look at those directories, my animations are not playing well on this. It keeps jumping. Okay, there. Oh, I see. It's playing up here, but it's not playing here. Got it. So now that I have the shell commands, and now that I have the directories, I can just run them on in terminal and get a look at what the actual output of that second task run outputs. And we'll see that whereas before it was text, it was a resource XML, now it's an actual binary file. And so this makes sense, right? So one of the improvements of the Android Gradle plugin for resource merging is it split the local merging and then the app merging and how efficiently it did that. It converts it from text to binary into something called a binary flat file. And then on the third run of the task, it's going to finally do the full merge. And that's going to result in that really long command. And it's going to have a binary zip file that is going to be eventually that resources binary file that gets packaged into your APK. And so there's a lot of, why does it do it this way? Well, the idea is that if you have a resource that's being consumed in multiple, you have a commons resource module, it's getting consumed in 3 or 4 other modules. They're trying to think of ways of how do you not crunch the resources multiple times. Another performance improvement that they did was the AAPT2 daemon. It used to, in the old Android Gradle plugin, shell out to this executable with a resource file and then got the output and then the process died. And it turns out that if you have really large projects, starting that process up and shutting it down for each module in your build is pretty expensive. So now what it does is it starts it as a daemon using that startup command, sends link and compile commands over a socket stream, and then also uses the Gradle worker API to have multiple daemons of AAPT2 running so that the entire thing can be parallelized and sharded. This has an adverse effect if you're not careful of taking up your heap space because now you have multiple daemons running instead of a single one, and they run out of the Gradle process. So it's useful to be aware of that, but the idea is that you can then shard these and scale them appropriately. Moving forward. And so now that we know we can shell out, we can avoid the Android, if you have a resource problem, you can avoid the Gradle plugin altogether for troubleshooting and just call the command line program. This is great for like Google issue tracker reports. I basically said this. Let's talk about processing the manifest. So if we process the manifest, one interesting thing here is that it is also an incremental task, but its due incremental task action is empty. So as of AGP 321, merging manifest is not an incremental task. You're always going to do a clean incremental, a clean manifest merge process. So again, if you have multiple modules and you're not using a build cache, this can incur some heavy I/O depending on your manifest configurations. So that's one learning. Digging in further, we see that pretty much the task delegates to something called a manifest merger. Again, similar to the resources, you expect it to just, it does the whole like node priority, attribute priority, that like node replace. You may be familiar where if you're merging 2 libraries that have a conflict on a certain node marker, you can prioritize that. Otherwise, it follows the priority like this. It's basically library modules get the lowest priority. If you're doing a variant build, the variant specific manifest would get priority, and then be overlapped by anything in the main manifest that it didn't define itself. So the variant will override the main manifest, I should say. And so there are very complicated rules available at the developer doc site on how this works. Another interesting thing from looking at that task is it provides a debug report. And so you can see every decision of every node and attribute in your merge manifest is logged here. And so if you see something that's funny, it's going to tell you why it made that decision point, what file offset, what line number. And again, it's a lot of data. You will probably almost never look at this. But the one time that you're going to see tools replace this and it didn't give you an appropriate suggestion, you can always fall back on this and go, oh, right, it's because I'm including Firebase or GCM is doing something weird. So it's a useful tool in the toolkit. Another thing is that the manifest merger has feature flags. And so you can do things like keep the intermediary stages. You can do things like advanced profiling. You could do things like resolving conflicts automatically. And again, dig in the source and see what other things are possible. But whenever I see feature flags, I get excited because then I can start tinkering with it myself and maybe learn a little bit more about the tool. All right, let's talk about r.java. I know I'm going over time and I will try to speed up because I know everyone's probably hungry. The only reason I bring up the r.java file is because it's about to change. You know, r.java has, you know, all those nice little properties, like it's just an array of ints and you never really look at it. Why is it even generated? And it turns out that it also affects build times because you are generating this array of ints. Even if you're compiling an AAR, you are generating this r.java and then throwing it away because inevitably AARs have to actually have something called r.text. Because it's a global resource pool, and the only one that can actually determine what goes in that global resource pool is the APK, which is the transitive closure of all the dependencies. But in order to form the r.text for the AAR, it has to actually generate r.java and then throw it away. And then on top of that, you have to do that for 100 modules and then merge all that into a resource pool. So you're basically doing unnecessary work. At Android Dev Summit, Chris Warrington, who works on the tools team, announced that they're going to stop providing r.java and instead give you an r.jar, which is going to have the class bytecode already written to it. And so you don't have to pay the burden of Java-C compilation for this pretty much useless file anyway. And what's even nicer is if you have a pure Kotlin module, you can bypass the Java-C compilation altogether. And there's huge benefits to this. It is feature flagged currently. I will show you how to enable that feature flag at the end of the talk. But it's good to know. And you don't really need to, whoever looks at the r.java file in their IDE anyway, like you really don't. What you really want to do is when you command click on r.id.string, it goes to the appropriate resource file, not the int array. Unless you're debugging roboelectric tests. That's probably the only other time. So, all right, so build config, the other thing. So remember I said that thing about pure Kotlin modules avoiding Java-C? Almost, because build config. Build config is this other thing where you can add variables to, and build config is this nasty thing that gets printed out, and it's really useless. You also generate this for every library module. It is also useless for every library module. You can actually disable this task. And so that's the actual like recommended advice I think Jake tweeted a couple of weeks ago is with the r.jar and disabling this task, you will bypass Java-C if you're a pure Kotlin module. So those are the tool tricks in your belt. Move everything to either pure Kotlin or pure Java, move Android to the surface, and then you can disable the tasks that don't mean anything, and that, along with modularizing, et cetera, will help build times over in that multi-pronged approach. Lint. The only reason I'm pointing out the lint jar task is because it shows what I think is one of the most exciting features of the Android Gradle plugin. It's not Lint itself, because Lint is killing build times and CI builds. If you want to learn about Lint a little more, I gave a talk about 2 years ago, a year and a half at DroidCon NYC that tells you how to write your own custom Lint checks, et cetera, et cetera. I'm not going to go over that now. That's the URL. I'll share it later. Also, Tor Norby at KotlinConf 2 years ago, or 2 KotlinConfs ago, also gave a really good talk on some of the stuff they're working on. So why do I bring it up? Because Lint gives a new configuration called lint checks where if you write your own custom lint checks and you put it in its own module, it will automatically apply those custom lint checks to the consuming project, which is kind of cool. But that's not even why I'm bringing it up. The reason is if we go to this method, get local custom lint checks, we'll see that in there's this interesting way of what this task actually does is it says, I'm going to look at the lint checks configuration, and I want to make sure that the only jar in that configuration is lint. Why else would you be packaging other jars if it's the lint check configuration? But the way that it does it is using something called the Artifact View API, which is what's new in AGP 3.0. And it's very powerful because think of not artifact as just jars and AARs. Think of artifacts as anything that's in your AAR, your ProGuard keep rules, your pre-processed jars, your post-processed jars, your lints, your assets, your resources. You can now basically query for any of those artifacts, and the AGP will automatically know which tasks publish those. And so, for example, you may have written custom code in the past where, let's say you wanted to post-process resources. You might have had to say, okay, iterate over every module that I depend on, and do a task depends on that task, and then just listen to the output directory. And that's fine, it worked, but you probably then, when you upgraded your Gradle plugin, broke that. So if you use this, it automatically does the wiring for you. You just say, hey, get me jars, and Gradle goes, cool, I'll find the task for you and wire them up as a pre-dependency. And you don't have to break between, it's basically an API versus hooking into the implementation. And they're finally offering this API, and it's pretty reliable. So again, if you look at the artifact type, this is how you would use it. Here's an example of it. And there was for some reason, the only good mention of this API was at the Gradle Summit by Zav 2 years ago. I keep on referencing this talk, even though it was 2 years ago, because this is the best talk on it. It has all the details, along with jumping into the source. So look up that talk at that bit.ly link. I'll share this afterward. Okay, I am running out of time. The last thing I want to mention is the transform API. So Jake gave a good talk at droidcon NYC and, about D8 and R8, so I'm not going to go into the details of that, but one of the things that's interesting is you could write your own bytecode transformations if you wanted to. D8 and R8 do it. Jetterfire does it if you are using Android X, but you have downstream dependencies that are still in support library. Jetterfire will do the bytecode rewriting for you, referencing the updated packages and including resources. It does that using a transform. So if you were so interested in rewriting bytecode, God bless you, but if you do that, you can with the transform API. This basically says what I just said. That's the talk by Jake. That's the link for it. The last thing I want to cover before I get kicked out is how do you improve your build. So I'm just going to show you this. This is the feature flag file for the Android Gradle plugin. It's awesome. Every time you find out on Twitter about this flag that you never knew existed, it's because they just found this file. This file has them all. And so what I like to do is I like to go to this file, look for the ones that are false, because the ones that are false are not enabled by default. That means that's the up-and-coming experimental stuff. So I like to play with that. Everything that's true, that's already shipped. So play with that, break your builds, and learn new things about the Android Gradle plugin. But things like resources being namespace, using R8 for everything, enabling the Gradle Worker API, having the r.jar as part of your build, you enable it using that. So everything's in there, experiment. Caching, if you're not enabling it, please do. It does improve local build times. Even if you're not using a remote cache, I've seen like 60% improvement just enabling that. And if you use capped, I lied, but then if you enable this, I less lie. It's actually pretty good with this. We have now with capped, and we do a bit of dependency injection in Kotlin. We only have like 40, 50 second incremental builds. And you can set that to a CI flag if you want. Variant filter, if you want to disable variants that you don't really need, you could do it that way. Profile your builds. You get a nice little report that can tell you like the low-hanging fruit that you can fix. Really what I like to go to, besides configuration time, is the task execution column. Know that lint and dexing are not cached at the moment. They're trying to work, they actually are working actively on fixing dexing, which is going to be a huge win. Lint is a topic of conversation that is currently underway. The Gradle Profiler, good open source project to check out and actually apply to your projects. And if you're so interested, Gradle also offers an enterprise solution that takes a lot of the stuff that you get out of Profile, but also adds some really nice UI and analysis tools that you might be interested in. I think Ruse and some members of the Gradle team are here. If you're so interested, have a chat with them. He's right over there. Cool. I do not get a kickback, I'm just being nice. So this timeline over here is really good for looking at like annotation processing usually, the things that are slowing down your builds, and it could be a symptom of like needing to modularize. And the last thing I'll leave you with is, I showed you the graph, the task graph, but it's also nice to look at your Gradle module dependency graph. And so at Square, we use this because we like to see how much progress are we making converting things from Java to Kotlin. So we have this nice little pie graph that kind of gives us a sense of how we're doing on that. And also, how many modules can we get Android out of and make them pure Java and Kotlin? Not only because the build times will be faster, but then if you're interested in things like Kotlin multi-platform and code sharing across iOS and Android, it also behooves you to like move all the platform-specific stuff to an API boundary. And so we do this, and we are pretty good at keeping things moving on that. If you're interested in similar code, Jake's SDK search project has a Gradle file that you can steal this out of. And finally, that's it. Thank you.